All right, so we're taking a deep dive into the fate of AI society today. It's by Kenneth James Hamer-Hodges.
Oh, yeah. I know that one.
And wow, um, some of these excerpts he sent over, they're pretty intense.
Yeah.
He's basically saying we got to completely rethink how we build computers, right?
Mm.
If we want AI to help us, not control us.
Yeah, Hamer-Hodges, his argument is that binary computers, the system we're using, is basically unchanged since the early mainframes, right? He says it's a recipe for disaster.
Wow. Okay. So he's saying the computers we're using now, which are basically powering everything.
Everything.
It's like a recipe for disaster.
Yeah. And he actually uses the term, get this, digital dictatorships.
Oh, digital dictatorships. Okay, that's a strong statement.
It is.
I mean, what does he even mean by that? And how does that even connect to AI?
Well, he's pointing to this fundamental imbalance of power in how binary computers work, right? With centralized operating systems, it means that control ultimately rests in the hands of just a few governments, big tech companies, anyone who can manipulate the code, really.
So that leaves individuals vulnerable.
Oh, absolutely. It's almost like we've built this incredibly powerful engine, AI, but we're installing it in a rickety old car with no safety features.
Okay, so it's not AI itself that's inherently dangerous, but it's more about the platform it's running on, right?
Right.
He's saying our current computer systems, they're fundamentally flawed, and this flaw makes AI a much bigger risk.
Exactly. Hamer-Hodges argues that this whole digital dictatorship structure gives those in control, it gives them the potential to manipulate our data,
Right.
our privacy, even our thoughts, and in ways we can't even understand yet, right? And as AI gets more and more powerful, the stakes just keep getting higher.
Yeah, it's a scary thought. We're kind of handing over these incredibly powerful tools to a system that might actually be working against us.
It's true.
So, but how did we even get here? Weren't early computers simpler? Didn't they empower individuals more?
Well, that's where Hamer-Hodges makes this really interesting point, right? He takes us back to the abacus and the slide rule,
Sure.
tools that really put mathematical power directly in the hands of the user.
Right.
I mean, they were transparent, they were secure, and they were reliable, right? Because they were so simple.
I'm starting to see the contrast here, right? So these tools were mechanical, they were analog, there was no hidden code, no operating system to exploit or anything. You could trust an abacus, because it was based on these clear, understandable principles.
Absolutely.
But then, as Hamer-Hodges explains it, we shifted to these binary computers, right? Embracing complexity and centralization.
Right.
And with that, we introduced this whole new level of vulnerability.
Yeah, it's like we abandoned the abacus, the simple tool that we could trust.
Yes.
And we went for this, fancy calculator that could be rigged to produce false results.
Yeah, basically. And now we're trying to run the most sophisticated AI programs on a system that's essentially a glorified version of that rigged calculator. Oh, wow. So that's a scary thought.
It is.
So he's saying binary computers are the problem. So where do we go from here?
Well,
Does he offer any solutions?
he does, and this is where things get really interesting. Hamer-Hodges actually suggests that the key to building a safer and more democratic AI society might actually lie in a concept from the very beginning of computer science, right? It's called the Church-Turing thesis.
Okay.
The Church-Turing thesis.
Okay, the Church-Turing thesis. It sounds kind of complex.
It is a bit of a mouthful.
Can you remind me what that is and how does it connect to all of this, these digital dictatorships we were just talking about?
Right. So the Church-Turing thesis, it basically says that any problem that can be solved step by step,
Right.
By a procedure can also be solved by this, simple theoretical computer called a Turing machine.
Okay.
It's a fundamental idea in computer science, right? It really helped define what it means for something to be computable.
Right. Yeah, I remember that from my computer science classes.
Right.
But I guess the question is, how does a theoretical computer from the really early days of computing, how does that help us solve the very real problems we're facing with AI today?
Right. Well, so that's the really fascinating part. So Hamer-Hodges argues that the Church-Turing thesis, it actually points us towards a completely different way of building computers.
Okay.
So instead of relying on these, centralized, these monolithic operating systems, he thinks we should be focusing on systems that are, more modular, more decentralized.
Okay, so modular and decentralized. So instead of one giant program controlling everything, we'd have lots of smaller programs working together.
Yeah, exactly.
Each with a specific purpose.
Precisely. And he calls it a functional implementation of the lambda calculus, which I know sounds really complicated,
Yeah.
but the idea is actually surprisingly simple. Think of it like building with Legos, right? Each Lego block has a specific function, and you can combine them in all sorts of ways to create, complex structures.
Okay, I think I'm starting to see the picture here. So instead of having like one giant vulnerable operating system controlling everything,
Yeah.
you'd have these smaller, self-contained modules
Yeah.
that can be assembled and reused.
Yes.
And since each module is designed to be secure, the whole system becomes more resilient. Is that right?
Exactly. And because these modules are independent, right, a security breach in one, it wouldn't necessarily compromise the whole system. It's just a much more robust approach.
Okay.
Especially when you're dealing with something as powerful as AI.
That makes a lot of sense.
Yeah.
And if we're worried about AI becoming uncontrollable, then building it on a system that's, inherently more secure and decentralized seems like a really smart move.
Yes.
It's like building a city with multiple power grids instead of just one.
Right.
If one grid goes down, the city doesn't go dark.
That's a great analogy. And Hamer-Hodges, he takes it even further, right? He actually argues that this approach to computing, it really mirrors how nature works.
Oh.
Think about like cells in an organism,
Right.
or ecosystems in the natural world.
Yeah.
Each unit, it operates independently, but it contributes to the larger system's, overall health and stability.
Yeah. So it's like building a computer system that mirrors the checks and balances that we see in nature.
Exactly.
Like no single point of failure, no single point of control.
Yes.
That's a really fascinating concept.
Yeah.
So has anyone ever actually thought about computing this way before?
Well, Hamer-Hodges, he actually points to Ada Lovelace, the 19th century mathematician,
Right.
The one who's often credited with writing the first computer program.
Right.
And he argues that she was already thinking along these lines back then, really emphasizing secure and modular design in her work.
Wait, Ada Lovelace, the daughter of Lord Byron.
Yeah.
I had no idea she was into computer science.
She was a true visionary. And Hamer-Hodges suggests that, if her approach to programming, which he calls functional programming,
Okay.
if that had been embraced by, the early pioneers of computing, we might have ended up with a very different and probably safer digital world today.
Yeah, it's incredible to think that someone from the 1800s could have anticipated these challenges that we're facing with AI now.
It's true.
It really highlights how some of these fundamental ideas have been kind of, overlooked
Yeah.
in this rush to build, bigger and faster computers.
That's right. And it really underscores Hamer-Hodges' larger point, right?
Right.
That we really need to revisit some of these foundational concepts if we want to create a truly secure and democratic AI society. I mean, he's not suggesting we, go back to using abacuses,
Right.
but he is advocating for this fundamental shift in our approach to computing.
Okay, so modularity and functional programming, it sounds good in theory. But how do we actually, translate these ideas into solutions for AI security?
Right.
It seems like we need to completely overhaul the way computers work. I mean.
Well, Hamer-Hodges, he actually gets into some specifics about that.
Okay.
He proposes this concept called capability-based addressing.
Okay.
It's a way of controlling access to, digital resources.
Okay.
Using these immutable tokens.
Okay.
Think of it like a system of digital keys.
Okay. I'm intrigued. Explain that a little more.
Okay, so imagine each piece of software on your computer
Okay.
having a unique key that gives it access only to the specific resources that it needs to function.
Right.
And that key is this capability token, right?
Right.
And it acts like this digital passport
Okay.
that limits what each program can do and what data it can access.
So instead of giving programs free reign over everything on my computer,
Yeah.
they would only have access to what they need to do their job.
Yeah.
And because these keys are immutable, they can't be copied or forged or anything.
Right.
Even by a hacker or a rogue AI program.
Exactly. It's a way of enforcing security at a much, much more granular level than we have right now.
Okay.
So with this capability-based addressing, you would have ultimate control over what happens on your computer.
Right.
Not, some faceless operating system or corporation.
Yeah. That sounds like a huge shift in power.
It is.
And a major step towards, like, addressing this whole digital dictatorship problem.
Yes, yes, absolutely.
But is this even possible with our current technology? I
Right.
mean, it seems like a radical departure from the way computers work right now.
Well, Hamer-Hodges, he actually argues that it's not just possible,
Right.
it's already been done. And he points to the Plessy PP250,
Okay.
a system developed back in the 1970s
Oh, wow.
that used a form of capability-based addressing to create a secure telecommunications network.
So there is a precedent for this kind of architecture.
There is.
It's not totally uncharted territory.
That's right. And Hamer-Hodges believes that the PP250 really demonstrates that this approach can work in the real world
Okay.
and that it could be adapted to meet the challenges of AI security today.
So it's amazing to think that we might have already had a solution to this problem decades ago,
I know, right?
but we went in a different direction.
We did.
It just highlights the importance of revisiting these fundamental ideas.
It really does. And that's a key takeaway from Hamer-Hodges' work, right?
Yeah.
The solutions to our, AI concerns, they don't lie just in developing smarter algorithms.
Right.
It's about creating a more secure and a more democratic foundation for those algorithms to run on.
Right. It's not just about the AI itself. It's about the environment we create for it to exist in.
Exactly.
So if we want a future where AI empowers individuals,
Yeah.
we need to build systems that actually reflect those values.
That's right.
Systems that prioritize security, that prioritize transparency and control.
That's a great summary of Hamer-Hodges' argument.
Okay.
But you know what? He doesn't just lay out the problem.
Right.
He actually offers this potential path forward.
Okay.
And that's what makes his work so compelling.
Okay, so we've gone from abacuses and slide rules to, theoretical computer science and digital keys.
It's been a journey.
It really has. It's been quite a journey through the fate of AI society.
Yeah.
But I think the question that remains is, what can we actually do about all this?
Well, Hamer-Hodges, he really emphasizes that this isn't just a problem for, computer scientists to solve. It's a societal issue, and it requires all of us to be, informed, to be engaged.
But so what can the average person do? I mean, most of us aren't, building new operating systems in our free time.
Well, Hamer-Hodges argues that we need to start by becoming more aware of the risks. We need to educate ourselves about, how these systems work and the potential consequences of, unchecked AI development.
So it's we need to develop this digital literacy.
Yes.
For the age of AI.
Exactly.
Understanding not just, how to use the technology,
right,
but how it can be used against us.
Absolutely. And with that awareness comes the power to demand change.
Right.
We need to hold the companies and the governments developing this technology, we need to hold them accountable.
Yeah.
Ask questions, demand transparency, and support initiatives that prioritize ethical and responsible AI development.
So it's about becoming informed citizens.
Yes.
Not just passive consumers of, all this new technology.
Exactly.
We can't just assume that the people in charge, that they have our best interests at heart, right?
Right, right. And Hamer-Hodges also encourages us to, support the development of alternative computing models, ones that we discussed, based on the Church-Turing thesis and capability-based addressing.
So even if we're not computer scientists ourselves, we can still advocate for a different kind of computing future.
We can.
One that's more aligned with our values.
Yes.
Of security and transparency and individual empowerment.
Precisely. It's about shaping the direction of AI development, right? Not just reacting to it after the fact.
Yeah.
And Hamer-Hodges, he really believes that this kind of collective action, it's essential if we want to avoid those, dystopian scenarios that he outlines in his book.
It's a powerful message.
It is.
And a call to action for all of us.
Yes.
So for our listener, what would you say is the key takeaway from all of this?
Well, I think Hamer-Hodges really reminds us that the future of AI society, it's not predetermined, right? It's something that we actively shape through our choices,
Yeah.
through our actions, through our demands.
Right.
We have the power to ensure that AI serves humanity,
Right.
not the other way around. But we need to be informed, we need to be engaged and willing to challenge the status quo.
So it's not just a prediction of, doom and gloom.
No.
It's a call to action.
It is.
It's a reminder that we all have a role to play in building the kind of future that we want to see.
And it's a reminder that even, these seemingly abstract concepts from like the early days of computing, they can offer these really valuable insights into, the challenges that we face today.
Yeah.
Sometimes the solutions to our most pressing problems,
Right.
they lie in rediscovering those fundamental principles that were overlooked, along the way.
I think that's a great point to end on.
Yeah,
I think this deep dive has really given you, our listener, a lot to think about.
a lot to chew on.
Yeah, a lot to chew on. So now it's time to, take that knowledge and decide how you will shape the future of AI society.
Right.